Welcome to this session, Managing NSX with Terraform.
All right, so real quick, the agenda. We're going to have a very short introduction about ourselves, why you should believe us, or why you shouldn't believe us, more appropriately. I'm going to give some information on why we do all this automation stuff in the first place. Since this is potentially, hopefully new for everyone, we're going to do a pretty, hopefully, extensive breakdown of what Terraform is, how it works. We're going to get into the architecture of it, and then we're going to explain how we run or ran Terraform at a previous customer of ours, and then hopefully we'll have done enough prayers to the demo gods for a few live demos as well.
Fingers crossed.
Fingers crossed. So who am I? I'm the guy on the left, in case it wasn't obvious. I'm Evert Amssoms. I'm a freelance infrastructure engineer. I've been doing this for a few years. I am a vExpert since last year, and since today also VCP VCF architect certified, so yay for me. And I guess I'm the unofficial Belgium VMUG hot spare.
I did not see you added that in there. Then our other co-worker, the Rocketdyne F1, is stuck in JSC, couldn't make it today. My name is Maarten Van Driessen. I'm a freelance infrastructure consultant based out of Belgium. Been a vExpert Pro since 2017, one of the Belgian VMUG leaders, and I completed the VCP VCF trifecta today here. So first off, why do we want to automate? Well, because we don't like doing things by hand. At a previous customer of ours, we were tasked with deploying and managing NSX when it was called back then. It's now NSX and vDefend, you should say. And we were thinking about how we were going to do this, and we were also going to be implementing microsegmentation. Now, we had a fair amount of applications going on there, and we were like, this is going to get out of hand really quickly if we don't think about an automated way to do this. So there were a number of things we thought of up front. We wanted to keep up with the rapid changes that were going to be asked of us. There was a lot of custom development going on, a lot of ad hoc stuff, so we wanted to be able to keep up with that while being secure. As I said, enable a default secure state. And because of that custom development, we also wanted to give some of that ownership back to the developers and the app owners once we were done with our secure baseline. We wanted to have easy permissions, as in nobody got permissions anywhere. We wanted to move to a read-only state of operation where we would have a couple of break glass accounts in case something breaks. But we wanted to do everything through code in an automated fashion, so nobody should have permissions. Working across silos was very important. He's a network engineer by trade. I was a system engineer by trade. We had a couple of platform engineers on there as well. So a lot of different backgrounds, and we wanted something that worked for everybody, no matter where they came from. And we also wanted to improve the responsibility and accountability because the umbrella sign is very applicable. As soon as something broke, it would come up. Nobody did something. We wanted to remediate that while we were doing this. So maybe a bit about what Terraform is. Terraform, in our view, is basically executable documentation. It's infrastructure as code. It's one of the more known infrastructure as code plays out there. It is a free open source tool. We created this slide deck when the whole BSL thing is in there or was applied in there. Watch this space. IBM purchased them, I think, 2 years ago at this point.
Yeah,
a year and a half, something like that. And it basically serves as an abstraction layer between your engineering and your APIs. So you don't need to figure out what API calls you need. You just run Terraform or type your Terraform code, and it'll do that abstraction layer for you. We're all virtualization people. We love abstraction. It is a single binary, kinda. You just download it, but that in itself doesn't really do much. We'll get back to that in a sec. You can run it locally, but you can also run it in a pipeline or use other platforms like Atlantis or F0 or Spacelift, whatever, to run Terraform for you. And he uses providers to manage all the operations. So Terraform in itself, as I said, doesn't know how to talk to vSphere, NSX, whatever. So you need providers to basically tell Terraform how to talk to a certain platform. And there's a lot of providers out there. Microsoft's got one for Azure, VMware's got one for NSX, AVI, vSphere, VCF even. Amazon's got theirs. There's a ton of providers out there. You can create your own if you're into Go. That is basically what that is.
All right, so a bit about the architecture of Terraform. Terraform has a concept of state. State is essentially the world as Terraform knows it. Anything that is not in Terraform's state file does not exist as far as Terraform is concerned. So what you'll see in there primarily is all the resources that Terraform is currently managing. Everything it has created, everything it will update, everything it could potentially delete. It can be local. And if you're just developing by yourself, that's a great way to start. Just have a state file local on your machine, or you could just put it on a remote backend. There's quite a few backends available. There's some HTTP-based ones. There's just a generic S3 backend. So with the upcoming VCF changes, you could just use the S3 object storage on vSAN for any Terraform state files. But it can also be on any hyperscaler, so you can just use an Azure storage account for blob storage to store them as well if you need it highly available and you can't really host it yourself. I cannot stress this enough, but the state file is one of the most important aspects of Terraform. Your state file contains potentially secrets. It also contains everything that Terraform knows about. If you break your state file in Terraform, you break all future deployments, potentially. If your state file leaks out, you're leaking your entire infrastructure out, or that part of it that you're managing, and potentially a bunch of passwords. So something to keep in mind if you start doing this stuff, state.
They did introduce sensitive variables in there that masks that in state, but it's not supported for everything yet, so just keep that in mind when you're developing new stuff.
Indeed. Next up, probably the part of Terraform you'd interact with the most if you actually start doing the stuff is your config files. So your config files is just going to be your actual code, the stuff you write, the stuff you want to exist, or the stuff that you say already exists. That's the stuff that essentially is going to be parsed by that binary Maarten was talking about before. So it's just going to go through all those state files, or all those config files, and try and figure out what it has to do. You'll recognize these by a TF or a TFVars extension. If you like writing it yourself, or generally if you write it yourself, you'll be doing this in HCL. It's a proprietary language that HashiCorp created for its tooling. You'll see something like Packer uses the same language. Or if you generate this, it can just be JSON, where essentially the HCL will be translated to JSON. HCL in itself is very much sort of a mixture between YAML and JSON as well, so it's pretty close. Now, once you actually have your code, you've done all your setup, you need to start running this. So first things first, you'll need an initialize. The command for that is Terraform init. And once you start doing this, once you run this, a few things are going to happen. First off, the binary is going to try and initialize your state file. Again, state is super important. You can't do anything without it. So depending on the config, the binary is then just going to go and create a state file, or it's going to open an existing state file, make sure it's all good. And of course, you define where it is, so it'll go looking for it wherever you say it has to go looking for it. It's also going to validate your syntax. So you're not going to be halfway through deployment and suddenly running into some weird error where you made a typo for trying to deploy, I don't know, a virtual machine. It's going to be fine. It's going to deal with that for you. It's going to download any providers it hasn't got in the cache. Ideally, if you're lucky, you'll be able to download these from the internet. If you're in an air-gapped environment, you'll have to set up some sort of Terraform equivalent of an offline depot. Both work. Doing it offline is very annoying because a lot of providers get very frequent updates. So if you have internet access, your life becomes a lot easier.
It's fun if you do that for a hackathon.
Definitely, yeah. If you ever do a hackathon at Explore, make sure you have that set up ahead of time. And finally, we'll get into modules a bit more later. It's going to download any modules that you might be using. Now, a plan without a dream is just a wish. If you're not familiar with Antoine de Saint-Exupéry, I can only recommend that you do get familiar with him. The man was very interesting, to say the least. So next up is a plan. So you've initialized. Terraform exists now. You have a state file. You've got all the required components to actually start doing something. So we're going to plan. I think this might be a bit hard to read, especially for the people in the back. The slides should be available, and then you'll have a higher resolution version of this. But essentially, you run a Terraform plan, or your platform runs a plan. And then what Terraform is going to do is going to look at its state file. It's going to look at all those resources. and it's actually going to refresh that. It's just going to do essentially an HTTP get to all the resources and get the latest version of the real-world counterpart of those resources. It's also going to parse all those config files you have in the particular folder that you're running it in, and it's going to compare that. So it's going to get a full list of the resources you want, it's going to get a full list of the resources you have, and it's going to compare that. Any resource in your config files, but not in your state, it's going to add that to a graph and say, I need to be creating this. Any differences between your config file and your state, Terraform is going to go, oh, I need to make a change to this to make sure that whatever is in my state file is going to match what you want. And anything that is in your state file, but not in your config, it's going to delete. Again, this is why state is very important. Once it's done all those things, it's going to take all those changes, those creations, those deletes, and it's going to add that to a dependency graph, because your providers make sure that Terraform actually knows about dependencies. It's not going to allow you to, for example, create a virtual machine and put it in a port group that does not yet exist. It's going to make sure that the dependencies are all taken care of, and it's going to create a file. Once you have that file, you have a plan, and you want to execute your plan. So you run Terraform apply. When you run Terraform apply, you have two options. You can just feed it the plan file, you can just create it. Or if it's maybe something that's ad hoc, you can just say, hey, generate a plan file on the go. If you are in full-on YOLO mode, you can also just say, auto-approve it. Don't think about it. Plan it, run it. Hope you don't see 150 resources have just been deleted. You'll have a bad time.
Don't ask us how we know.
Yeah. Friends don't let friends run auto-approve in production.
No.
That's all I'm going to say about that. Once it's executed the changes that it wants to do, it's also going to record all those changes in a new version of the state file. And then finally, the modules. So if you're curious, Terraform has a concept of modules. Now, what is a module? A module is just a folder. Any folder with Terraform files in it is considered a module. The module where you run the binary is considered the root module, hence, well, root, right? Makes sense. And it's just a set of code, and ideally, why do you use this? You use this to adhere to the dry principle. Dry, do not repeat yourself. If you are building things with Terraform, you can end up with massive files, and you're just repeating yourself all the time. All right, I want a VM. So if you build a VM, I assume most of you are not just, right-clicking in vSphere, new VM, and then just doing the whole thing by hand. You use templates. Modules are essentially the same thing. You use templates. Why do you want this? Again, the dry principle. It saves you a bunch of time. It saves you a bunch of refactoring. If you ever have to make a change to something globally, you don't have to be editing 5,000 resources. You just update the module, increase the version, slowly roll that out. It also allows you to avoid many small outages because you're handcrafting those small resources. Got to be careful, though. If you mess up with your module updates, you might be introducing one very big outage, the downsides of automation that we may have all run into. It also allows you to enforce standards. You tell people to use a module, your module will contain your standards. So you don't allow someone to just go and do their own thing. Say, hey, no, this is what we use. We've given this to you. Use this, please, and it will have all the standards that we want you to use. And finally, it's an extra layer of abstraction. Generally, if someone wants a VM, they'll usually know what OS they want on it. They'll know how much disk space they want. They'll hopefully know how much CPU and memory they want, but they might not know how many tags are needed for the specific environment, for example. You can do all that stuff through a module.
So a bit about how we ran Terraform. We've moved on since, but this is how we implemented it at a previous customer. We wanted to avoid running Terraform on our endpoints. The benefit, as we alluded to, state file. State is saved locally or remotely, depending on where you run it, but we didn't want a sprawl of secrets across everybody's laptop, because that would generally be a bad time, because we wanted to have it as secure as possible. We also wanted to have as many modules as possible. As Evert said, we don't want people to actually think about how they're going to do it. We'll do that for them, or the platform team did that for them. They just need to deploy their infrastructure the way they want it and be done with it. And we wanted to limit write access to basically anything that could be managed by Terraform. We also wanted to use an IAC platform because we didn't want to run Terraform on endpoints. We kind of wanted to have something that managed that for us. So what we ended up doing is do management through pull requests. So whenever somebody needed to do something new, they would create a new pull request in Azure DevOps is what we were using. Submit that pull request, have somebody else approve it because we wanted to adhere to the 4IS principle. We didn't want somebody YOLOing stuff into production. We wanted actual review of what was happening and not seeing that there's 115 deletes and 2 adds, because that would generally be a bad time if there's no change record associated with it. That management platform should also run everything through, that is related to Terraform Plan and Apply. So it'll have all the secrets or access to all the secrets. And because it's in Git, full traceability, commit history, you can see exactly what happened, who approved something, who actually created something, which was a good addition. So we've bored you enough. I see a couple people snoring in the back. So let's go to demos. And we checked them in my room before. Is this readable? Let me ask this first.
Should we zoom this in maybe for someone, or is it good?
Zoom. All right. I'm not going to do the plus thing because Mac to Windows is a bad time. Zoom in. Maybe once more. So first thing we're going to do is a Terraform init. Now, we already did that before because my lab was a bit slow today from an internet point of view. Whenever you do an init, you download all the providers, all the modules. The NSX provider is something about 100 megs large, and it took us 3 minutes to download it before, so we just did that for every single folder. Just remember, whatever folder you're working in, you need to do an init in there so that Terraform will initialize that folder for you. Cool. So first things first, Terraform will need to know what providers it's going to use. So that is what is in that Terraform block. Here you tell Terraform what provider it's going to use. And by default, if you do the source like this, it will look on the Terraform registry. You can use other registries, but then you need to change the way the source URL is formatted. And we also say we want to use version 3.3.0 of the provider because we know this one works. It's got no breaking changes for our existing code. That's why we fixed those versions in there. Cool. Now Terraform knows how to talk to NSX, but it can't actually do that. It doesn't know what NSX manager I have, what service account to use, so that's where the provider configuration comes in. So here we give it a provider NSXT. This is a logical name that we just use. I could make this banana. It will work. It's just to keep it logical for yourself. So we're going to tell it the host is SBI NSX Manager. That is the NSX Manager that I'm running in my lab. Give it a username. Ignore SSL certificates, and max retries is 2 because I wanted to retry 2 times if it's not working, and stop there. Cool, but there's no password in there. I didn't want to show a password in here, and it's generally a bad idea of putting passwords in code. It's in my override.tf file here, and I will show you. This password is just here. It doesn't really matter. Here, you will override anything that is in any other Terraform block, and you just say, OK, just add this in there. I could also change the username in here, and it would just override what's in the other file. Cool. That's that. Now, there is a concept of data blocks. Data blocks are a way of telling Terraform to get information somewhere that it can use in its code somewhere else. So by default, whenever you're creating, for example, a tier 1, which is what we're going to do, and a segment, you need to attach a tier 1 to a tier 0. Now, we've already created a tier 0 in my lab, but I need to tell Terraform what the name of that tier 0 is so that it can query that object through the API. So here I'm creating the data block of the type NSXT policy tier 0 gateway. I'm giving it a logical name for myself, which is tier 0, and I'm telling it to get the tier 0 gateway that has the name tier 0-GW.
Might be useful to know. If that looks very overwhelming, all those names, no one is expected to know this stuff by heart. At some point, you start knowing a few of them by using them,
yes.
But generally, all the exact names for data and resources are documented in the provider as well. So if you go to the Terraform registry, which I don't think we can do right now per se, but you'll see full lists of all the objects that the provider implements. And generally, those will map to an API. And ideally, if you have a somewhat decent API, that will actually map to objects that you recognize from using it in the UI, for example.
Yes. Cool, so we've got the tier 0. Now we also need to get transport zones, because that's also important in NSX. So you need to have some knowledge of the platform you're automating for, but as Evert alluded to, it will tell you what it actually needs before going on. And if you just try to run it, it'll say, I have no clue what I'm doing with this, please give me that information. So I'm getting the transport zones here, so creating new data objects of the type NSXT policy transport zone, giving it the name tz_overlay and tz_VLAN. Cool. Now we're going to actually create something, and when you create something or remove something, update it, it is a resource. A resource is something that Terraform has complete control over. If you make changes to something that Terraform has created and saved in its state file, you're going to have a bad time if you change that outside of Terraform. So whenever you see a resource or you've defined a resource, just do all of the management through Terraform, or you will run into broken state files and stuff like that, which is generally when you start having a bad time. So here we're going to create a tier 1. I'm going to create a new resource of the type tier 1 gateway, giving it a name t1-explore. Just adding in a bunch of names, description, display name, some other stuff that NSX needs to actually create that. And here you'll see the tier 0 path is the data object we created earlier. So whenever you're reusing something that you already queried, you use data dot the type of the object that you created, and then the name. And usually, depending on the provider, it's either .path or .id, so that you get the unique identifier in the API and hand that over to Terraform. Now, creating a tier 1 is all good, but we also want to create a segment. So here we're creating another resource of the type policy segment and giving that the name ls-explore-01. The display name will be the same, and I'm reusing the data object for the transport zone, but then I'm also reusing, and if that stupid popover would go, I'm also reusing the tier 1 that we created before. And here you'll notice that you don't prefix that with either data or resource. Terraform knows what it is, so you can just give that short path of the type dot the name and then dot path or ID, depending on the provider you're creating. Cool. Let's actually run this, and let me open up a new terminal. So it said I already created the, or did the initialize, so we're gonna run the plan. It'll take a sec, and then it'll spew out a bunch of stuff that you will want to read, otherwise you have no clue what's going on. So here you'll see Terraform is going to create a resource, a segment, ls-explore-01. It's got the name that we provided, it's got the CIDR that we provided, and then it also says it's going to create a tier 1-explore, cool. But as I said before, you need to have a tier 1 before you can have a segment. The order of things in Terraform here or in the output of Terraform doesn't matter. It will figure out in what way to apply it. So keep that in mind when you're reviewing something. The order in which it's displayed could differ from the way it's going to actually implement that. Cool. So I'm going to run an apply now. And it's going to spew out that plan again, but then ask for a confirmation. So I'm going to go yes. And you'll see, OK, this is done. Now, I'm not one to trust the automation platform, so let me just verify this. And we should have opened this before. 01. And Firefox has decided to take a break. Live demos are the best. There we go. Just ignore these alarms. It's a lab. It's fine. So you'll see there's a new tier 1-explore created and a new segment, hopefully ls-explore-1. Cool. Imagine doing this on scale. This is going to suck. So we want to make this better. So that's where we go into demo 2. So you'll see the same kind of things pop up, but there's more files here. So let's go back to the main. The main looks completely different than the one it did before. Here we define a module, and we'll get back to the rest of this, but where's the information for talking to NSX? Well, we moved that into provider.tf. And here it's got the same block, Terraform, the NSX provider, and the way it's going to talk to that NSX manager. It's important to keep in mind that Terraform does not care how many files there are, if it's one big file, if it's a million small files. It will just lump those in together and run this. This is to make it easy for the meat machines, so you can actually understand what you're doing when you're dealing with complex environments. So provider.tf is where we did everything related to the provider. Now, since we're using a module, we're also using variables, so we have to define the variables that we're using. In here, we're using two variables that we called segments_native and variable location. One is of the type string, and one is of the type map. A map is basically just an array of objects. You can type it. You could also create a map of strings, map of integers. It's basically what you do in certain programming languages. But it's important to set the correct type for what you're going to be defining later on. Cool, so we defined those variables. So what are we going to do in the main.tf? We are going to loop through the modules, or we are going to loop through the variable segments native, I should say. For each object that is in that map, it will just loop over that and perform what is defined underneath there. So we're going to define a location, that is variable location. And anytime it runs over that, it will take the value of the number and the value of the CIDR object and put that in those other variables. This is very abstract, but it will become clear once I switch over to this file. And here you'll see I have the segments native map. What's in there is explore-03, 02 went on a vacation. And we just have a number and a CIDR for every object within that map. I could create Explorer 69, for example, do number 69, create a different CIDR. It will loop through that. The memeing is very real, I apologize. Sorry. Terminal, let's run this. Demo 2. We already ran the init Terraform. So let's do the plan. And now it's asking me for a value, but we already defined this value. Terraform will lump everything together, but you actually need to tell it which variable file to use, because you could have multiple in the same folder. So as soon as Terraform, yeah, it's mad at me now. So let's use the var file explore.tfvars. And it is doing a whole bunch more. So what it's going to do, it's going to gather the resources we created earlier, the tier 0 again, the tier 1. It's going to gather the transport zones and all that stuff. And then it's also going to create explore-3. And I kept it very consistent between the object name and the actual display name. That's why I was confused. Keep that in mind so you don't end up like I'm here. It's doing that with the subnet that we've defined. Cool. So let's just change plan to apply here. And just blindly trust what it's saying. Do as I say, not as I do. And it's created a single segment. So let's go here and refresh. Hey, look, it created ls-explore3 with the CIDR we've defined. I'm handing it over to Evert now.
All right, that's all nice and dandy, or fine and dandy. I'm sure if you're doing stuff with NSX, and especially if you do stuff with vDefend, our presentation was made before choices were made regarding naming. But you probably want, if you're doing vDefend, you probably want some firewall rules. And you're probably thinking, I maybe want to do this at scale. This is like, yeah, that's good. I have one tier 1 gateway. I have one segment. That's not going to do it. I need more of this. So we have got, for the last demo, a bit more of a larger environment. It's nothing massive. It's nothing like production. Well, again, it's a demo. So what we've done here is we've actually added a few more modules. So you can see here we'll have a module for services, and that module is going to create, well, services. TCP ports, UDP ports, maybe in groups, maybe in names, whatever you want it. We'll have a module that will deal with security groups for us. And then we'll have some data objects to actually get built-in services in groups. This can be very useful. I don't know about you guys, but I prefer using built-in services when possible. I don't need 70 people creating a new HTTPS service. That just makes my life more difficult. I'll just use the built-in HTTPS service. Thank you very much. And then finally, we've got a module that is going to create the policy for us. Again, this is where modules become very powerful, because as you can see, an NSX policy can be a fairly large and complicated affair. There's a lot of knobs that you can twist. There's a lot of variables you can put in. We have written a module, in our case, that just applied to our environment, to our organization, where we just go, all right, so give us all the groups, and give us all the services that you might want to use, and then give us all the rules that you maybe want, or all the rules. And we'll just build it for you. Give us some input, and we'll just take all that, and we'll just give you policies instead. What you'll also see in this particular version is that we've now got a remote backend. Local backends, again, that's nice. You're doing it by yourself, but this is maybe a bit more production-like, so you probably want your state file somewhere else. So what we do here is, in our Terraform block, where we've defined our providers, we're also saying, all right, but I would like my backend to be on Azure in this instance. So we give the resource group name, we give the storage account name. If you're not familiar with Azure, I'm sorry. It's a bit out of scope to explain all of this, but essentially, we're just telling Terraform, there's a storage account, it has folders, make a file there, this is what the file should be named, and just dump state in there. Finally, you'll also see that our tf-vars file is now a bit larger. So we've got some groups in there. Again, outside of the scope, but best practice, whenever you can, build your security groups with tags. Makes your life much easier. Don't use IPs if you can avoid it.
Or direct assignment.
Or direct assignment, yeah. Definitely not direct assignment. But yeah, we've got some groups that we want. So some of them are based on tags. Some of them are based on IP addresses for reasons which I will not get into in this instance.
It was mainly for Avi. That's the short of it.
We've got some services here. We've defined some stuff for Azure AD, Entra Now, some stuff for Active Directory, some stuff for our certificate authorities that we needed, some stuff for Citrix, I think, if I'm not mistaken. And then we've got a list of all the built-in services that we might want to use. So all the stuff you see in here is just, these are services that NSX just ships with. You don't have to use this, but again, no need to reinvent the wheel. And then finally, the bulk of it is policies. Yes. So what we have done is create a bunch of policies. I'm not going to go over every single one of them, don't worry. I won't keep you here for another 5 hours. But if you're familiar with NSX policies, this will hopefully look very familiar to you. We've created a policy. We've called it ICMP. This is just our map item, our map name rather, but we'll be reusing that for our policy name. It's going to be an infrastructure policy. It has a sequence number, and it has a bunch of rules in it. And those rules, well, what do they say? They need a display name. They need some sources, or any, if you don't fill anything in. Ideally, some destinations, some services, allow, drop, the usual. You might want to negate some stuff. You might want to log stuff. You might not want to log stuff. All of that just goes into this one vars file. Just to prove that we're not talking out of our asses here, there currently is no policy. So it's not like we're just showing you an NSX and then we're just doing something, logging into a different manager. There is nothing here.
You should show the infrastructure tab instead of the app tab.
And I should probably show the correct tab, yeah. That's actually a very good point. So again, there is nothing actually in here. Thank you for pointing that out.
You're welcome.
So first things first, since we're now using remote state, we actually need to log in to Azure. This is very much another one of those do as I say, don't as I do. And I'm failing at basic computing, as I usually do. So if you do this in production environment, again, you'd have this sort of stuff built in your pipelines, built in your platform, where your secret would not just be right there for everyone to see.
The way we did it in production was we used Atlantis, and it would just log in anytime we actually needed to run Terraform. And as soon as it was done, it would log out, and secrets were no longer in memory either. So that's a way you would do that in production.
Yeah. So in this instance, I'm just going to skip the plan, since we're not going to use the output plan, and you'll see, all right, we're going to add 19 resources. And you'll see, for example, we're going to create a service for TCP 515. It's going to have a display name. Stuff like ID, path, a lot of this stuff is generated or computed as you create the resources by the API. You can't really output an ID for something that doesn't exist yet, so you'll see known after apply. But you will see here, in our port set entry, we are doing port 515, and it's going to be on TCP. If I scroll up a bit, you'll hopefully see that we built some other stuff as well. And you'll see we have a policy, and the rules are coming into view. There we go. So we're going to create a policy. In this case, we're going to call it domain, some stuff that will be known after the apply. And we're going to attach some rules to it, an allow action in this case, and we're going to allow our Active Directory to talk to our domain controllers, or allow service devices to talk Active Directory to our domain controllers, generally best practice. So we're happy with this. Just a tip, if you ever start doing this, a quick way to review plans, if they're very large and you know that they come from a somewhat trusted source, is to look at how many changes there's going to be. If you make a change and you expect 4 changes, and you see your plan is going to add 4 things or update 4 things, brilliant. If you don't expect anything to be deleted, and you see some sort of 3, like some, I don't know, some like, again, the 150 destroys or changes, that should probably be setting off some alarms in your head before you apply it.
Yes.
So now you see we've applied, we've refreshed, and then now we have policies. If you now ever want to add to those policies, it's really just a matter of updating our TF-vars file, adding new policies, deleting policies, adding rules. In a non-demo environment, you'd actually have this code on Git, some sort of Git implementation, GitHub, Azure DevOps, GitLab, whatever you want to be using in your organization. Talk to your developers. They'll probably have something already if you don't. You'll make a pull request, as Maarten said before, and then you'll just have that go through a change management, that whole shebang, and then apply it, and there you go.
We could probably show the modules now since we have a bit of time.
Yes, we do have some spare time.
Let me just...
Those modules that we have, again, you could host those in your Git repository, but just like there is a registry for providers, you can have a registry for modules. There's modules on HashiCorp's public registry. I generally advise against using those unless it's for testing. What someone else writes probably won't apply exactly to you. It can be a good starting point, but should probably not be used exactly. In this instance, Maarten has an account on the HashiCorp Terraform Cloud and has uploaded our NSX module. I'm not sure which one this was.
This is the NSX module that I used in demo 2. You can see there's a bunch of inputs that it requests: a location, a number, a segment CIDR, which is optional. It'll outline what resources it's going to create. You could add a changelog.md in there, and it would show whatever is changed between versions. And you'll also see that, hey, this is not actually hosted on here. The source code is just on my GitHub page. So you could look at the actual source code of that specific module. This is all publicly available. Feel free to abuse it afterwards. So this is a way to create that mapping and have that control. You could create new versions of your modules independently of what you're doing into production. So as soon as you change the module version in your actual source control of your Terraform repository, that's when that new module will come into play. So it gives you options to develop new things or new features in your modules and testing them somewhere else before actually implementing them into production. Because sometimes there might be breaking changes, like whenever a provider decides that disks have a different name than what's written in the documentation, and you have to recreate all your disks.
Don't ask us how we know.
I think with that, we're getting close to the end. So please, 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 everybody, fill in your survey.
Yeah,
or good. Else.
Yeah.
Are there any questions? Yeah.
You mentioned earlier that when you make changes to Terraform, don't make changes to the actual environment, make changes to the code. So would you generate a new Terraform file with just those changes, or would you do the changes in the original Terraform deployment and just apply that? Like, for example, if you're changing a hosting, you just change the host and rerun the whole thing? Or?
Yeah.
We would generally create a new branch in our repository and then try to merge that branch through a pull request, and it'll show you the diff of what's happening and output what it's going to do. If you're doing that on VMs, the way we did it is on first boot, we passed through a PowerShell script, so it would not run again because we put that in the ignore block, which we found out the hard way. Because if you change the host name for Terraform, that is like, oh, that deployment variable has changed. I'm going to redeploy this VM for you now, because that's what you asked me to. So there are certain things that you will want to change through manually, like a host name of a VM inside the VM. But there's other things that you actually have to do. Increasing of CPU, for example. If a colleague did arrange downtime, they increased the CPU from 2 to 4, but they have not made that change into Terraform. Next time you run a Terraform apply, it's going to be like, this is wrong, buy VM, revert it to 2 CPUs, but you will have unexpected downtime because it needs to shut down that VM, and it does not have any concept of maintenance window, so it'll just go. So that's important to keep in mind. Yeah?
A couple of years ago, there was a concept where Terraform was going to be able to document your cloud platform for you.
Yeah, it very much does, because when we mentioned it, executable documentation, a lot of this depends on the size of your infrastructure. There's a bunch of third-party tooling that will do this for you as well. But since everything you have exists in code, ideally, it's hard to brownfield Terraform. We should have probably mentioned that. But you have that documentation, because everything you have, it's just all there in the repositories. So I'm not going to say it's trivial if you want to do it yourself. There are tools out there, but you can just parse your state files, parse your config files, and get a fairly decent overview of everything you have, assuming it's not entirely fragmented. And even so, you can just combine the data there.
I was thinking about you doing it from like an NSXV to NSXT migration, thing with hardware.
Those should be done already. I get that. It's very hard to brownfield. We were very lucky that we were able to greenfield this, and we were like, okay, as from this date, anything new will be in Terraform. The rest will slowly die off. But it's very hard. Yeah. There was a question in the back there.
I was just going to ask a question on like how you structure like where you put like your NSX stuff. So say you have like a service, so you have an app server and database and stuff like that. Would you put your NSX stuff in with it, or would you keep it completely separate?
Like many of that stuff, of these things, the answer is it depends. One thing that really pays off when you're doing infrastructure as code is in general is having a good, long, hard think before you start with it, and really building out and designing what you want your repository or your infrastructure to look like. Terraform is not a replacement for having a good data center design, but building a good repository or a good structure of repositories is very important. What we did in our case, for example, is we had one massive repository for our data center infrastructure. The organization was small enough to do that. That doesn't work for everyone. But we'd have it split up. We'd have folders for compute, folders for networking, folders for security, and then in our folders for security, we'd create a module, really, where we'd manage all our groups and services, and then different modules for different business units, for different environments, and just have the rule base in there.
Important to mention there is we did that also to limit our blast radius, because if anything goes wrong with state, then it would only be limited to the VMs in development for that specific tenant instead of the data center is gone,
Exactly.
which was highly favorable in our case.
Anyone else?
Yeah.
So you mentioned that the state file should be somewhere else, not hosted locally.
Mm-hmm.
So maybe there's some examples how to do the whole stuff.
Yeah.
This is just a demo.
Yeah, exactly. It's hard to do. The last demo had the state file in an Azure storage account. That was a pre-existing storage account. I should probably add that, and you can get into long discussions about chicken or egg if you want to maybe create that storage account with Terraform as well. That was just in, but that last one is just in Azure Storage. That could just be on an S3 bucket. That could be in HashiCorp console if you happen to be running that. There's a few ways to do that. As long as you just keep it away from your laptop and away from your source control. Don't put your state file in your Git. That's also a very bad idea. Again, secrets in there.
If you use Spacelift or M0 or Terraform Cloud or any of those platforms, your state lives in that SaaS, and that also eliminates the you having to manage it. So there's ways of easily doing that, but you will pay for that. And pricing is generally based on amount of state files or workspaces or stuff like that.
Okay, so variables and TF files on a gate,
Yeah.
Yep.
with all the approvals,
Mm-hmm.
and the state files somewhere.
Somewhere where ideally no human can access it.
Exactly.
The way we did it, for example, that was just a dedicated storage account, and the only access to that storage account outside of our Azure super users, our global admins, was just the service account that ran Terraform for us. Nothing else had access to that, because no one should be touching that.
And we just had the AZ login we showed before. We just had that run in the container whenever Atlantis run, which was the platform that we used. It's an open source tool. Highly recommend you check it out. But Atlantis would just run the AZ login with environment variables that it would get from a different key vault. So there's no real secrets. Eventually, you're going to have a secret somewhere, because you can't dynamically get that because it will need to authenticate to it. But we jumped through a couple of hoops before we actually got to the good credentials, and then that was only available for that specific user to be accessed the storage account. So, and I think our time is up now.
So the door's just
We'll be around for the rest of the day if you've got more questions with that. Thank you. And please fill in your survey or Dave will find you.